Hi, this is going to be my presentation on algae biofuels, an eco-friendly alternative to petroleum fuels. So the research question I have posed today is, how can algae biofuels be used to make airplane fuels more eco-friendly? Some background research is, travel by air has been significantly increasing year to year, and it will double in the next 15 years. The graph here shows that the aviation industry is a major contributor of carbon emission in the transportation industry. Many of the other industries have already taken a sustainable approach by finding alternatives to reduce the carbon footprint and lower travel pollution. The International Air Transport Association is already looking at ways to reduce carbon emissions and bring this down to zero by 2050. The goals presented by this review paper will be the advantages of alternative aviation fuels made up of algae biofuels, the benefits of sustainable aviation fuel when produced at scale, and techniques on how to increase mass production of algae fuels. There is a major initiative by the government to reduce carbon emissions and to target net zero carbon emissions by 2050. Sustainable aviation fuel is made up of fuel such as agricultural crops and microorganisms like algae. Sustainable aviation fuel is more climate friendly and are made from renewable resources. Sustainable aviation fuel is also quite similar to fossil fuel and can be a great alternative to fossil fuels. Although SAFs provide many benefits, they only make up 1% of the aviation fuel used today. This is due to the low supply of SAFs, which result in a higher cost compared to petroleum fuels. What are algae-based biofuels? So to first investigate that, we have to go into what is algae. Algae is simple unicellular organisms. They perform photosynthesis and they reduce the presence of carbon dioxide in the atmosphere. They are also highly adaptive to marine and freshwater environments. Algae biofuel is made from this algae, and they produce 30 times more oil than their predecessors based on crops. This is going to be a comparison on jet fuel, also known as aviation fuel, versus SAF fuels. The increase in pollution caused due to petroleum fuel has led the airline industry to look for alternative sustainable approaches. The substances that are emitted from the burning of traditional fuels are detrimental to the environment. Substances like carbon dioxide, carbon monoxide, and nitrogen oxides are normally emitted. Studies show that burning fossil fuels produces about 21.3 billion tons of carbon dioxide annually. These large amounts of emissions are leading causes of global warming. About half of the carbon dioxide emissions from energy use were due to petroleum fuels in 2021. 3% of the nation's greenhouse gases are produced from petroleum fuels. Algae biofuels, on the other hand, leave a significantly less footprint on the ecosystem and may eliminate up to 60% of the carbon dioxide emissions in comparison to petroleum fuels. Burning 1 gallon of algae fuels emits over 2,000 grams of carbon dioxide, whereas fuel emits over 16,000 grams of carbon dioxide for the same amount of fuel. To reduce pollution, SAFs are now used in conjunction along with traditional kerosene fuel. This mixed combination of traditional and biofuel has been used in many commercial flights after the commercial certification for SAFs were approved in 2011. More than 250,000 flights have been powered by this mixed combination of fuel. The mixture can be 10 to 50% of SAFs mixed with the rest being traditional fossil fuels. The goal is to eventually move towards a full-scale replacement of 100% SAF usage for aviation fuels. Unfortunately, even in these times with such a negative impact to the climate, there are proposals to increase the 40 million flights a year, and this is possible due to aviation subsidies. These aviation subsidies encourage aviation sectors to have a continuous growth in airplanes flown per year. Data leads to an increase in air traffic every 15 years and indicates that air traffic has doubled between 2015 to 2019, causing a 33% increase in carbon emissions. The airline industry has had many government subsidies over the years, which have promoted the avoidance of more climate-friendly alternative approaches for jet fuels. Aviation subsidies are defined as cost benefit that are provided to aviation consumers and producers. In fact, there are current tax benefits like a zero tax policy or minimal tax burden on international flights. However, there are new subsidies that have been created for renewable jet fuels and a plan put in place for extending the current tax credits for sustainable fuels to 2031. The biofuel subsidies are part of the clean energy incentive. To qualify for this subsidy, the sustainable fuel has to prove 50% less carbon emission when compared to traditional jet fuel. Biden's FY22 budget plan includes a tax credit proposal for a new sustainable fuel tax credit. The sustainability of algae-based fuels is based on its mass production methods. There are currently many studies that are in progress to find out efficient and cost-effective mechanisms of algae production. One economically feasible mechanism is to mass produce algae by increasing the lipid yields in microalgae without impacting the growth or the biomass. Lipids are organic compounds that naturally include these oils. Through metabolic engineering, transgenic strains are developed which help increase lipid accumulation and yields. Transgenic strains are when organisms undergo some form of genome transformation. Studies indicate that this process of biofuel production is economical and can be easily adapted and used widely. Although a viable solution in terms of mass production, there's a lot of improvement required in terms of enhancing the efficiency to increase production and reduce the cost. Aquafarming is yet another method by which the production of biofuel can be quite cost-effective. This process involves raising fish for food and using fish waste for biofuels. This has proven to be quite efficient. This method involves extracting oils from fish waste and is mixed with methanol and other products for microalgae cultivation. Bioenergy Technology Office supports the research and development of sustainable use of biomass resources for mass production of biofuels. Alganol, a biotechnology company, has an algae strain that helps in the production of ethanol directly and has a mechanism to convert biomass into hydrogen fuels, which are used for jet fuels. Alganol has proven to exceed its productivity of ethanol and hydrocarbon fuels to around 10,000 gallons collectively per acre per year. Algae growth has been severely impacted due to sunlight penetration, and bioreactors help alleviate this dependency by allowing for the adjustment of light and temperature to promote the successful mass production of algae. Additional research is also done by the Texas A&M research scientist Joshua Young to use artificial intelligence, which can reliably predict the light needed to promote the growth of algae. Joshua's patented prediction model will allow for the synthetic production of algae at scale. Algae production is largely hindered due to harvesting costs. However, Yuan's research overcomes this challenge through machine learning techniques to regulate and sustain cell growth in algae. Now summarizing a few key points of my presentation. First, algae-based biofuel is a great alternative to petroleum fuel. The reasons why it is a great alternative is because it can be grown independently and does not compete with food crops. This makes it an extremely attractive approach. The second reason is because it absorbs carbon dioxide emissions, hence reducing carbon emissions in the atmosphere. Another key takeaway is that the cost to cultivate and mass produce algae is high. As the production of algae increases, the cost will decrease. But to do this, we need to address challenges concerning mass production. Investments are being done in research and development, especially in the fields of biotechnology, genetic engineering, and artificial intelligence to address the mass production challenges. These techniques will help us meet our long-term sustainability goals to attain a safer atmosphere and environment. To put my review paper together, I refer to the following articles, which I've listed here. Thank you for listening to my presentation. Are there any questions?
Thank you, Kushaan. I do have one question, but I'm going to hold it off until the end because we're running really close on time. Thank you very much for your presentation.
Thank you.